Today I am explaining chapter 2. Chapter 2 talks about atoms, molecules, and also we learn about ions in the chapter 2. It begins with the history, how these subatomic particles, what are the experiments that scientists did to identify these, discover subatomic particles, and then we're going to learn the other important concepts, atomic mass, and isotopes, like that. So at the beginning of the chapter, you need to know three main laws about the structure of atom: law of constant composition, law of conservation of mass, and law of multiple proportions. And then these three basic laws help Dalton to identify Dalton's atomic theory. Dalton's atomic theory is very important. Dalton's atomic theory, he explained four important concepts, which is each element is composed of extremely small particles called atoms. All atoms in a given element is identical, but atoms of one element is different from atoms of other element. And atoms of one element, third point is atoms of one element cannot interchange to atoms of other element in a reaction. And also he also talk about atoms cannot destroyed or created. And then compounds are formed when atoms of more than one element combine. Given compound always has exact type and number of atoms. That is Dalton's atomic theory. After Dalton's atomic theory, scientists discovered subatomic particles. Subatomic particles, the particles in atom, three different subatomic particles: protons, electrons, neutrons. Protons and neutrons inside the nucleus, and then electrons outside the nucleus. If I show you, like the atom is, there's a nucleus, and around the nucleus there are electrons. Electrons around the nucleus, inside the nucleus, protons and neutrons. Protons are positively charged, electrons are negatively charged, neutrons is neutral, no charge. And the scientist who discovered the electron, they did cathode ray experiment and also Millikan's oil drop experiment. And also you need to know about radioactivity. Henry Becquerel, Marie Curie, and Pierre Curie, they did a lot of experiments on radioactivity. When they do radioactivity, they discovered three different types of radioactive particles: alpha, beta, gamma. So even though I draw this structure at that time, scientists, they don't know this is the atomic structure. So scientists were looking to find the structure for the atom. And J.J. Thompson is a scientist, came up with the first structure for the atom. He came up with the plum pudding model. Here I have shown you the plum pudding model. We have positively charged sphere, negatively charged electrons embedded on the positively charged sphere. That's the structure he proposed. But his student Rutherford, he doesn't want to agree to this plum pudding model, so he keep on doing the experiments. And then he did the Rutherford's gold foil experiment. In Rutherford gold foil experiment, he discovered the structure of atom is not what the J.J. Thompson proposed. Okay, now let's see what is Rutherford's gold foil experiment. Rutherford did more experiments and he want to come up with the structure for atom. So what he did, this is the source for alpha particle. For alpha particles, and then he passed it through gold foil. Gold foil is it's something like aluminum foil, very thin piece of metal. And then his results was remarkable. When he passed these alpha particles through gold foil, what he noticed, majority of the particles passed through this gold foil, but 1 in 12 million particles, that means extremely small amount of particles, didn't go through. It deflects back. Why it deflects back? If the if atom is made out of like a positive charged sphere, it should be dense, right? And but then he came up with the idea, atom, most of the atom space is empty. matter is mostly made out of empty spaces, the mass is condensed and compact in a small region. That small region is called nucleus. So that's how they came up with the structure for the atom. So this is the atomic structure. It is the small region is nucleus, and around the nucleus the electrons are rotating around the nucleus. So this nucleus is small region. So that is the Rutherford's coal-foil experiment. And then we are moving to our next part, which is these terminologies. You need to know what is atomic number. Atomic number, number of protons in an element. Number of protons is unique. It's defined an element. Always, if carbon always has 6 protons, oxygen has 8, hydrogen has 1. In that way, you define, it's a unique property for each element. Mass number is number of protons and neutrons in an element is the mass number. So you can use this notation to represent an element. So it's, you write in a symbol name, below you write 6 is atomic number, 12 is mass number. So the 6 is atomic number, which is number of protons. So this is atomic number, number of protons, and this is mass number, protons plus neutrons. Protons plus neutrons. This is the way of representing an element. And then isotopes. What are the isotopes? Isotopes are the elements that have same number of protons but different number of neutrons. When you have different number of neutrons, you have different masses. So example, hydrogen 1, 1, hydrogen 1, 2, hydrogen 1, 3. Those are isotopes. Hydrogen, deuterium, tritium. And then you should have some knowledge about atomic mass units and atomic weights. Weight is the mass of all the isotopes. Average mass of all the isotope is atomic weight. And then you have to go to periodic table. Periodic table arranged according to the increasing atomic number of elements. It groups the vertical lines we call groups or families. Why we call groups or families? Because they have similar properties. And horizontal lines, periods. And it has periodic table is classified into metals, non-metals, and also metalloids. And when we go in this chapter in the course, you will see again periodic table we can classify into different blocks: S block, P block, D block, and F block as well. Because groups or families, they share similar properties. Group 1 metals, group 1 sodium, potassium, rubidium, cesium. Group 1 we call alkali metals. Group 2 alkali earth metals. Group 6 chalcogens, 7 halogens, and group 8 noble gases. And then the chemical formulas. Chemical formula is how you represent a compound. There are 3 main ways you can represent a compound: empirical formula, molecular formula, structural formula. Empirical formula is simplest whole number ratio between atoms. In example, sometimes empirical formula and molecular formula can be same. Molecular formula is most commonly used formula. It can be mostly multiples of molecular formula. Structural formula give most of the information. It gives you number of atoms, types of atoms, as well as the attachment also. So if I take an example for empirical formula and molecular formula, let's take glucose. Glucose molecular formula is C6H12O6. So this is the molecular formula, most commonly used formula. It gives you types of atoms. So you know when you look at the formula, okay, glucose molecule has carbon, hydrogen, oxygen. And also you know you have 6 carbons, 12 hydrogens, 6 oxygens. So this is the information from molecular formula. What is empirical formula? Simplest whole number ratio. It gives you just the ratio between atoms. So you have to find the common factor, which is 6. You divide, and then CH2O is empirical formula for glucose. This is molecular formula. Structural formula is you show even the attachment of glucose. And let's take another example, carbon dioxide, CO2. What is the, this is molecular formula. Can you simplify this anymore? You can't simplify it anymore. So that means in that case, empirical formula and molecular formula is same. Now in this chapter, you need to know some basic idea about the types of compounds. There are two types of compounds, ionic compounds, covalent compounds. Ionic compounds formed by complete transfer of electron from one atom to another atom. It's like giving you a present. So ionic compound, they're always complete transfer of electrons, metal and a non-metal. So always in ionic compound there is a metal and a non-metal. Metal loses electrons, non-metal gains electron. And there is another type of compound which is covalent. In covalent there's no giving electron. They have two atoms, they completely share electrons. Example for ionic compound is sodium chloride. In sodium chloride, sodium loses its electron, completely loses its electron. Chlorine gets that electron. Covalent compound example is water. In water, they share electrons. And then in order to know about ionic compounds, you need to know about ions. Ions, there are two types of ions, cations and anions. Cations are the positively charged ions, and ions are the negative charged ions. Cations form, metals form cations, non-metals form anions. Cations form by losing electrons, non-metals form by gaining electron. So that's the about the compounds, and with that we are moving to nomenclature, naming. How do you name these compounds? We learn ionic compounds, covalent compound, and also their acids. Ionic compound always is made out of metal and a non-metal. So always when you name the metal first, and then you write the anion plus ide. Example for one compound. Let's see how do you name sodium chloride, NaCl. So you write sodium, metal name, chloride. It's not chlorine, you write chloride, sodium chloride. So this is one type. Example, there are two types of metals in chemistry. There are certain metals, that's easy. They only form one type of cations. You know metals form cations. One type of cation. But there are metals in the D block or transition metals, example copper. They make more than one type of cations. In your lectures you can see I have given list. The metals form one type of cation. Example, alkali metals. Alkali earth metals, group 3 like aluminum, silver, zinc, they always form one type of cation. That's easy. But whenever you have the metal that form more than one type of cation, example copper. Copper form copper 1 plus, copper plus 1, copper 2 plus. So let's write copper oxide. Copper oxide, copper, oxygen. CuO. So oxygen always 2. Charge for the oxide anion is 2. How do you name copper oxide? So oxygen always need 2 electrons to go to the noble gas configuration. So it form anion is, it is anion, this is cation. Cation loses 2 electrons, oxygen gain that 2 electrons. So if it is anion, copper 2 plus means it loses 2 electrons. That 2 electrons gained by oxygen. So if you have to name this one, you name copper parenthesis. You need to write the charge oxide. But how you name this one? Cu2O. That means you need 2 copper ions. This one you name copper 1 oxide. So you need to know the nomenclature of naming the ionic compounds made out of metals form one type of cations and metals form 2 types of cations. And then we are moving to covalent compounds. Covalent compounds, basically example, made out of 2 non-metals. Example CO2, carbon dioxide. 2, you always need to use prefixes. Carbon dioxides. How do you name this one? N2O5. Dinitrogen, because always number of atoms you need to list it. So it's dinitrogen pentoxide. And then we are moving to naming of acids. There are two types of acids: binary acids, oxyacids. Binary acids made out of only two atoms, hydrogen and another atom, which is it is Hi. It is always in a binary acid you write hydro and then an ion and you add ic at the end. Always in the binary acid you write hydro, ic and acid. That is how you name binary acids. Two atoms: hydroiodic, hydrochloric acid, hydrobromic acid. There is another type of acid made out of oxyanions, sulfuric. So you name oxy acids using the anion. So this anion is sulfate. Anions end with 8, acid become, you remove the 8 and add sulfuric acid. Example, let's take another example, nitric acid, HNO3. How do you name this one? What is the anion here? Nitrate. Ends with 8. You remove 8 and write nitric acid. For when you name oxyacids, you don't want to write hydro. You write hydro only in the binary acids.